Hello and good days. My name is Khairul Huzaimi and I will be presenting about the mini project for roof trusses, and the subject is DCC 40142 for steel structure design. This is me. My name is Khairul Huzaimi that I told the previous ago, and my matrix number is 07DKA20F1019. Roof trusses are load-bearing frames constructed of connected triangular shapes. They take advantage of a triangle's natural attributes, its strength and its stability. The members forming the triangles have pin joints. These types of joints have the property that all the bending moments within the truss are eliminated. The members making up the truss are either in compression or tension, unlike beams which experience tension and compression at the same time. This is the reason that trusses are more efficient at supporting loads over wider spans than simple beams. Not that other not that other types of joints such as gang nailing are used in roof trusses. The tension and compression competence for these are different to those for pin joints. This is the comparison of roof truss and beams. Uh, the loads from the roof sheets transferred to the purlin are as follows. Dead load on slope or GK, corrugated steel roofing 0.1 kN square, lighting and insulation is 0.15 kN square, surf weight of purlins is 0.147 kN square, surf weight of trusses is 0.2 kN square, total dead load on slope or GK is 0.6 kN square, imposed load on slope or QK is 1.8 kN square. The detail of the truss is spacing between the truss or the ST is 7 meter and pulling spacing is 4 meter. So the solution is we factor load Q is the formula we know 1.35 GK plus 1.5 QK. So we got 1.0.6 for GK and we got QK for 1.8 kN square. So we just put it inside the bracket. So we got the 3.51 kilonewton meter square. So this is what we got 3.51, 3.51, 3.51, 1.8 because uh, we divided by 2. We use moment clockwise for or to get the reaction forces. So we just need to use the moment that we already learned from the theory of structure or mechanical or Moses. So we got V vertical A equals to vertical D is 0.07 kilonewton. We we use same the formula that we learned from the theory of structure. So we got first FAEY is negative 5.27. So the arrow will go to down. So after that we calculate the FAEX equals to 8.51. The arrow will go to left. So we use the formula for Pythagoras theorem, if I'm not mistaken. So the FAE is 10 kilonewton. So the 10 kilonewton is compression. So after that we calculate or we solve the uh, force to the right equals to force to the left. So FAB is equal to 8.51 kilonewton. So FAB is a tension. Maximum tension is 8.51 kN. Maximum compression is 10 kilonewton. So the maximum. So we go to the next step is to determine the properties, table of properties. So the maximum design of tension force in truss member is 8.51 kN. The member consists of an unequal angle of 80 times 60 times 7L of steel grade as 27.5. So we got this from the table properties of unequal angle. So the tension load we solve for the design string from table 3.1. T is 7 millimeter, or the is uh, smaller than 40 millimeter. So the steel grade is S275. So the Fy is 275 Newton per millimeter square, and Fu is 450 Newton over millimeter square. Diameter of board is 20 millimeter. So we got from the glossa 6.2.3. So the NPL or RD per RD equals to AFY per YMO, or NU uh, per RD equals to 0.9 A net FU is equals to 1. We know that's 1, right? The design plastic resistance of cross section is NPL RD. NPL RD equals to 938 times 275 times 10 negative 3 over 1. So we got 258 kilonewton. The design ultimate resistance of net cross section at odds for fasteners, or NURD, is from we got 0.9 times 6 to 3.85 times 430 times 10 the power of 9 the power of negative 3 equals to 1.25. So we got 193.14 kilonewton. So the NTRD equals to 193.14 kilonewton. So we check from the NED equals to NTRD smaller than 1. So we got 0.04, that smaller than 1. So this section is suitable to carry the tension force. So after that, the connected with weld. We got it from clause 6.2.3, same as the previous thing. The design pressure resistance same is the same. So the design ultimate resistance of the net cross section at all for fasteners NURD. NURD is this is the same that I talked, and the NTRD is 290.40 because this uh, area is not minus with the board, the 20 millimeter board. This got minus from the 20 millimeter board. From the clause 6.2.3 formula 6.5, we check it. NED is the maximum tension, so we got it 8.51. NTRD is over 290.40, smaller than 1, so we got 10, my bad, 0.04, smaller than 1. It is suitable to calculate the tension force because it is smaller than 1. This one compressor load is we got it from the table properties for of an unequal angle at T times 60 times 7 L. So design strength, we check it from the table 3.1, Eurocode table 3.1. We design check it. T 7 millimeter is smaller than 40, so it's all good. Table 5.2 sheet factor of 3. Fy equals to 275 Newton over millimeter square. Fu equals to 43 Newton over millimeter square. So the classification of cross section is H over T equals to 80 over 7. So the answer 11.43, smaller than 50 times 0.92 is 30.8. B plus H over 2T. B breadth plus H height. So 80 breadth plus 60 height over 2 bracket 7 smaller than 9, 11.5 times 0 9.92, so the answer will be 10.51. The smallest radius of gyration is IY 25.1 will contribute the largest LCR, and BB is the weakest axis. Note that the larger the slenderness, the weaker is the axis buckling resistance about the weakest axis. VV axis is NVBRD. Clause 6.3.1.1 formula 6.47. This one is the formula. When the capacity of relation factor is given as clause 6.3.1.2, so the XV is the formula is this one is given clause 6.1.3 LCR equals to 1.0 L because this is the length. Because of the pin, we use it 3 meter turns to 3000 millimeter. This one formula we got it from Eurocode. 93.9 is time 0.92 80, so we got it 86.39. So from the LCR 3000 over 28 12.8 plus 1 over 36.39 86.39 we got it from LCR, so the equals to 2.71, so the answer will be 2.71. Table 6.2 buckling of B. Table 6.1 for buckling of B is imperfection A equals to 0.34. So this from the clause 6.3.1.2 0 0.5 bracket 1 plus 0.34 bracket 2.71 minus 0.2 plus 2.71 the power of 2 equals to 4.6. So 1 over 4.6 we got it from the previous step plus square root 4.6 the power of 2 minus 2.71 the power of 2 we got it the answer 0.12 and VVRD 0.12 times 938 times 275 times 10 the power of negative 3 over 1 30.75 kilonewton. We check it, and ED is the design maximum force tension compression force over NVVRD 30.75 is smaller than 1 because it 0.32 it is suitable to carry the compression force. And that's all from me. Thank you for listening, and I'm very thankful for this presentation to be end.